This video is about the sum and difference identities of the other trig functions. We did cosine already, and this is for sine and tangent. Please make sure before you watch this video that you've printed off a copy of the note sheet. It'll help you if you're writing along with me and taking notes as opposed to just printing off my notes. So, in order to start off, we need to refresh ourselves on a couple identities. The first one we need to refresh ourselves on is the cofunction identity. We know that the sine of theta is equal to the cosine of 90 degrees minus theta, or equal to the cosine of pi over 2 minus theta. And this, of course, was true because if we had a right triangle, if there's 90 degrees here, we still have 90 degrees left. So if this is theta, this here is going to be 90 degrees minus theta. And whatever the cosine is of this, the adjacent over the hypotenuse, it will be equal to the opposite of the hypotenuse of 90 minus theta. So that's the first identity we need to remind ourselves of. And the second one is the difference of cosine. The cosine of u minus v from yesterday was equal to cosine of u, cosine of v, plus the sine of u times the sine of v. So today we're going to talk about the derivation for sine of u plus v. Well, if we use our cofunction identity, we can replace the angle u plus v. If I'm thinking of u plus v as being an angle, I can say the sine of u plus v is really equal to the cosine of 90 degrees minus angle u plus v. But we're going to be doing it in radians, so let's go ahead and replace that. And we will instead say that's equal to the cosine of pi over 2. In fact, let's go ahead and distribute through pi over 2 minus u minus v. So I went ahead and I distributed through the minus sign. So minus u minus v. Well, if I think of it this way, I can actually break up that angle. So I can say that's really equal to the cosine of pi over 2 minus u, that's my first angle, minus my second angle, so minus v. And now I have two angles. My first angle is pi over 2 minus u, and my second angle is v, so I can go ahead and use the cosine difference of two angles formula, and I can say that's equal to the cosine of pi over 2 minus u, that's cosine u, times the cosine of angle v, then plus the sine of pi over 2 minus u times the sine of angle v. Well, cosine of pi over 2 minus u, in fact, I'm going to write this over here. The cosine of pi over 2 minus u is equal to the sine of u, cofunctions. And the sine of pi over 2 minus u is equal to, of course, the cosine of u. So let's just go ahead and do some substitution in there, and we get that's equal to the sine of u times the cosine of angle v plus the plus the cosine of u times the sine of v. So the sine of angle u plus v is equal to the sine of u times the cosine of v plus the cosine of u times the sine of v. We can do the exact same thing for the sine of u minus v, so let's. We can say that the sine of u minus v, we can use cofunctions, that's going to be equal to the cosine of pi over 2 minus u plus v. If I distribute it through, I'll write cosine of pi over 2 minus u minus v. And then when I distribute that through, we get that's equal to the cosine of pi over 2 minus u plus v. And then, of course, we can split up that angle again. And remember, the associative property of addition says we're allowed to put in some parentheses. We're allowed to regroup it as long as we remember to redistribute a negative if we have to. So that's equal to the cosine of pi over 2 minus u, that's my first angle, plus v. Well, I know that the cosine of u plus v is equal to the cosine of u, which in this case is pi over 2 minus u, times the cosine of v, minus the sine of pi over 2 minus u, times the sine of v. And again, substituting using our cofunctions, that's going to get us equal to the sine of u, because the cosine of pi over 2 minus u equals the sine of u times the cosine of v minus the cosine of u times the sine of v. So the question asks us, compare the formulas for sine of u minus v and sine of u plus v. How are they different and how are they alike? Well, we'll start with obviously how they're alike. It's the sine of one angle times the cosine of the other, plus the cosine of that first angle times the sine of the other for the u plus v. How are they different? Well, they have opposite signs. And interestingly enough, the sine of u minus v is equal to, as we said, sine u cos v minus the cosine of u sine of v. Similarly, the sine of u plus v is equal to the sine of u cosine of v plus the cosine of u sine of v. And to help us remember this, we have a little saying, and it's sine, same, sine, with the sine being gn. So what that means is if we're adding the two angles, u plus v, then when we're expanding that out, sine u cos v, it's going to be plus sine u sine v. Same if it was minus, it would be minus also. The implication there, of course, is sine is the same sign, so cosines are opposite signs. And we talked about that yesterday. So the cosine of u minus v, of course, was equal to cosine u cosine of v plus the sine of u. Oh, sine of u sine of v. So we've got two new ones. So we've got the cosines, we've got the sines. So let's do the tangents. The tangent, of course, is sine over cosine. So let's just go ahead and replace that. We can say the tangent of u plus v is equal to the sine of u plus v divided by the cosine of u plus v. You know, as long as we have an angle, tangent of theta equals sine theta over cosine theta. So even if it's two angles being added together, sine of u plus v, it's going to be equal to over the cosine of u plus v. As long as the angles are the same, that's equal to the tangent of that. So let's go ahead and expand out with our new formulas and our old formulas. So tangent of u plus v is equal to sine u cosine v plus cosine u sine v divided by, well, cosine u cosine v minus sine u sine v. Well, this looks a little ugly, and what we want to do is simplify it. So just like when we did the trig identities, what we're going to do is let's go ahead and multiply by a form of 1, which will give us something to make our life a little bit easier. In this case, the one that we're going to do, and you'll see why we chose this one, is going to be 1 divided by cos u cos v. So we're multiplying top and bottom by 1 divided by cos u cos v. So let's go ahead and distribute out, see what happens. We get sine u cosine of v divided by cos u cos v plus cosine u sine of v divided by cos u cos v, all over, in my denominator, cos u cos v divided by cos u cos v, minus sine u sine v divided by cos u cos v. So let's go ahead and do a little simplifying here. In the first term, I can remove a cosine of v, and I can remove a cosine of u in the next one. So I'm left with sine of u over cosine of u plus sine of v over cosine of v. In the denominator, well, my first term just becomes 1 minus sine u over cosine of u times sine of v divided by cosine of v. Of course, all those sine of one angle divided by cosine of the same angle, we can just replace all of those with tangents. So our final identity will be tangent of u plus tangent of v divided by 1 minus tangent of u times tangent of v. So the tangent of u plus v is equal to tangent of u plus tangent of v, that quantity divided by 1 minus the tangent of u times the tangent of v. We can do the exact same thing for the difference of tangents. And if you look at the formula, the way we got it, notice that our numerator was sine of u plus v. And we know that sine u plus v equals sine u cosine v plus cosine u cosine v. So our numerator had a plus in the numerator. Similarly, cosine of u plus v, our denominator has subtraction sign. So as we look at tangent of u minus v, we can probably predict what's going to be happening with our numerator and denominator of what happens when we verify this identity. But let's go ahead and do it. So, or I should say derive this identity. So the tangent of u minus v is going to be equal to the sine of u minus v divided by the cosine of u minus v, which is equal to sine u cosine of v minus cosine of u sine of v divided by cosine of u cosine of v plus sine of u sine of v. We're again going to multiply by a clever form of 1. And we're going to choose the exact same one. We're going to multiply by 1 divided by cos u cos v. And very similar things are going to happen with this one. So we now have sine u cos v divided by cos u cos v minus cos u sine v divided by cos u cos v, all divided by cos u cos v divided by cos u cos v plus sine u sine v divided by cos u cos v. And we can go ahead and remove our forms of 1. We've got cosine v's, we've got cosine u's, and v's, and whoa, this should have been, what we got going on here? Yep, we're good. So that's equal to sine of u over cosine of u minus sine of v over cosine of v, all divided by 1 minus sine u over cos u times sine v over cos v, which is equal to tan u minus tan of v divided by 1, whoops, that was a plus, plus tan u tan v. So how are these formulas alike? Well, the tangent of u plus v has a plus in the numerator. The tangent of u minus v has a minus, a subtraction sign in the numerator.